Hello, everybody. Marc Cymontkowski, VP of Engineering at Haivision. I want to talk about media routing in the cloud today. Solution that's called SRT Hub. You know probably that we open source a protocol called SRT. I don't want to go into the details. It's meant for transmission of low latency data, especially video, optimized for video, over the public internet. So we're getting a lot of attention. A lot of people are using it by now. And we have used it to implement a newsroom in the cloud for Al Jazeera. The advantage of the protocol there is that basically the different cloud solutions that you have, no matter where they are located, you can connect them through SRT as like what we call glue, like glue stuff together. Have different people working on the project. We worked on Microsoft Azure. We worked with Make TV, different high scale for transcoding. So all kinds of providers came together, and we put this thing together with SRT as a connecting piece. It works very well, but there is challenges, right? So if you look at the challenges that we have is, how do you cover unpredictable events? If something happens that you didn't expect, there's a lot of manual process involved to check this. How are you getting your content in the cloud? I mean, luckily we have SRT, so that is the smallest problem, but maybe your cloud solution is not running where you are located, like for me in Europe. Maybe the ingest point is somewhere in the US, right? So I have to do contribution to that point. If I use our media gateway, which is a Haivision product, it's very, very cool because I can fire up cloud instances across the planet and then route SRT through on the Azure backbone, which gives me really good throughput, but I have to do it manually. I have to fire up the instances, I have to configure the ingest, I have to configure the output. So that's time consuming. This workflow is not scalable. So for 1, 2, 3, 10, 20, it's okay. But what if I do 5,000 events at the same time? I have to maintain the infrastructure, so I have to check all the time, is the system up, are all the cloud instances running okay, are my containers stable, like all this stuff. And I want to integrate third-party production solution, right? I want to connect all kinds of vendors in this ecosystem. So we thought we build a solution that can basically fulfill all these requirements. So what we did is we looked at where are the important events happening and are the resources available. So it could be worldwide, right? So if we leverage the cloud, which makes a lot of sense, we could cover basically the planet. So we work with Azure in this case. They have 54 regions worldwide. So we can use these regions to run ingest points, egress points, workers, all kinds of stuff. We can do it on demand and we can scale. So if we add SRT to the game, then we basically can connect the different regions over the Azure backbone with the SRT protocol, which makes it a routing over the backbone of Azure. Very powerful combination. Now, we can take our equipment, we took all our equipment, Haivision equipment, our encoders, our decoders, set-top boxes, our media gateway, and we hooked it up to the solution so we can go end to end, right? From an encoder through the delivery network all the way to the destination. But we thought, what if others can connect into this system? So we came up with a plugin model, which we call Haplits, and I will explain them later, where you can build a plugin to the system so you can route from a third-party solution to whatever other third-party solution, or to ours, whatever, across the cloud. Now this becomes SRT Hub. That's what it is, right? It's a virtual routing service in the cloud. If now what we did is, if you add IoT control to the device, it makes it really powerful, because now you can go to, say, an encoder once, you put in a pairing code, it registers over IoT to the SRT Hub, and it shows up in your account. Because now you have one virtual dashboard, and you can select like the source device, this specific stream, and you can select where do I want to route it across the backbone and where do I want to end it. And again, even the output devices could be registered in the system. So you can create end-to-end workflows, including third-party services, devices, cloud solutions. So SRT Hub is media routing in the cloud. It's using secure, reliable global routing. It's live and file-based. Since the SRT protocol is really content agnostic, you could route through anything. Right now, we build it for broadcast because that makes a lot of sense to connect the different broadcast solutions that are out there, that are partially cloud-based, that are partially devices, services. So yeah, built especially for broadcasters at this point. The API is fully accessible. So it's a dashboard where you log in and you can do everything manually, but it's all built on APIs, so you can directly access the APIs and integrate it into your solution. So the SRT Hub becomes the back end of your solution. It's a cloud-native microservice architecture, so it can run redundant, it's reliable, we can monitor everything in the cloud. And very important, it's extensible by third-party solutions, so-called Haplits, plugins into the system. And a Haplit could be something on the input. So how do you get your content into the SRT world, into the SRT Hub world? It could be a processing component that can receive SRT, output SRT, and do something to the content, like a transcoder, analytics, machine learning component, a graphics overlay. And it could be an output Haplet, where a lot of output Haplets would be, for example, components that allow you to hand the stream off to a different cloud solution. So we demoed some of these Haplets at NAB. For example, Wowzer created a Haplet themselves, hooked it into the SRT Hub solution. We were able to do contribution across the planet to the data center where Wowzer had their instance running, and they were doing the delivery to the end customers. So what is a Haplet? At the end of the day, it's a container with a defined API that we specify. Depending on whether it's an input, a processing, or an output Haplet, it has SRT inputs and outputs, and it has a worker in there, obviously. So that worker could be running in the container. So you're doing something that runs on that container you created, or your container is basically a loophole service that redirects the traffic to your service. So you can, if it's an output, it's simple, right? SRT is coming in. You reroute the data to wherever you want it to get. You would run that Haplet in the data center where your solution is running. So there's no problem on the contribution side. So you use the SRT Hub system to do the contribution and then hand it over in the destination data center. If you look at the architecture, we have an example here. So we come with an on-prem encoder with SRT into the West Europe region. We have a replicator container running, sends it to 2 different regions, China East and US East. And then depending on how the workflow is, there could be more replicators to multiply the stream, go into a processing Haplet, go into an output Haplet, send it over to a third-party cloud service. And again, this could be the same in a different region. So you could cover multiple regions. If you look at that, this is look at the UI, where you can see on the left side your dashboard, where basically you can monitor the health of all your routes in one dashboard. Basically, you see if there's something red, there's a problem, so you can click in and you can see what the problem is. If something is orange, there's probably something not perfectly right, like maybe congestion on the network. But all that in one view, and you will have some standard metrics immediately available, so you know, okay, everything's good, I don't need to care, or there's a problem, I have to dig deeper here. And in the center, you see a typical workflow being created. So somebody put together Haplets. There's an input Haplet to ingest the stream. Either it's from a cloud service, either it's from an IoT registered device, or it's a generic Haplet. So we have a Haplet that accepts on the input UDP, RTMP, RTP, and converts it into SRT. That's also available as an installable component. So basically, instead of having a device registered over IoT to the SRT Hub. You have a software component you install on a Windows desktop or a Mac desktop. It registers on the SRT Hub, and it runs a local ingest kind of on that machine. So you could do local host RTMP to that connector component, and it sends SRT from your desktop or server over the public internet into the SRT Hub. It's basically the same mechanism of registering the devices, but it's a software component that you can install. Then on the right side, in the center here, you can see a list of all the hublets that are available, whether you want to create an input, a processing, or an output. And once you created all your routes, you have an overview of the routes. There's different views that you can select, whether you want to see them just all in a list, like being green, yellow, red. Green if all is good, yellow if there's maybe a potential problem, red if there's really a problem. And you can also dig deeper into a container level view. So if there's a problem, you can have analytics where you go deeper and say, okay, it's probably this container. Then you dive into it and you can see what the telemetry of the container is telling you. Is it something that's coming from the worker? Is the actual worker having a problem? Is the container having a problem? Maybe the region has a problem. And we try to assemble all of this telemetry in one place. And going forward, we have ideas about how we use all this telemetry that is coming up 24/7 and how we can analyze it and make the service auto-adjust itself to become better and recommend values for you for some of the configurations. So the end goal is to make it as simple as possible, so you don't have to know the details. The system will recommend workflows for you. On the below, so the idea here is having a really intuitive user interface, route everything end-to-end SRT, because it's, and the reason is A, because we have it, and B, because it's content agnostic. So right now it would be, for example, an MPEG-TS, but it could be anything. And since we also support file transfer with the protocol, it's not only live streams, but we could route basically files end-to-end through one-to-one or one-to-many. In the background, there's an automated routing engine running, and the orchestration in the background is intelligent. So if you, for example, ingest in one region, you want to do transcode, and then you want to output in 3 different other regions, then the orchestrator in the background says, okay, it doesn't make any sense to do 3 transcode in the destination regions. I do the transcode in the input region. And the more complex your workflow becomes, the more this intelligence is important, because it tells you where is the best location for a certain service. Right? And that could also depend on the third-party hublet that you have, because the third-party hublet provided by a different vendor maybe is only available in 3 regions out of the 54. So then the orchestrator in the background needs to know that information and has to optimize the workflow according to that. Flexible connector hublets, we talked about that, and the Azure Cloud Region Scale. That's the key part here. Having the 54 regions, having the Azure backbone to ride across, super critical. What do we build this for? Most importantly, live broadcast contribution. So how do I get my content from where I am on-prem to the data center, to the region where I want to process the data. So it could be that you just use the SRT Hub to get data from on-prem encoder to some destination region where you run your own service, and you go out with a generic SRT Hub. But it could be a very advanced workflow, as I showed you before. And the second use case is live production distribution, where you come in one place and you have different affiliates getting the content 24/7. Could be, again, a very simple, just routing use case, or it could be very advanced, including transcoding, ad insertion, overlay, all of these things. This is an example that we ran at NAB. So we had a Makito encoder input in one region, running over the SRT Hub. In the second region, going out to a Makito decoder, doing end-to-end 500 milliseconds latency. Going out in the third region and writing to Azure Blob Storage for archiving this live stream. So there's a hublet that we created with Microsoft to write the live stream into Azure Blob Storage directly. And the second workflow we had running is, again, coming in with an encoder, sending SRT into one region, running over the SRT Hub, going into an output hublet that Epic Labs created, which was using machine learning or is using machine learning, looking at the content, optimizing the transcoding depending on the content, bringing it down, reducing the bit rate of the content by 40% roughly, package it low latency CMAF, and hand it over to Akamai for delivery, and we achieved roughly 3 seconds end-to-end latency on this. And we also sent it to a third region where we had a proof of concept running of our new peer-to-peer implementation that we did, which we will add to the SRT framework. We announced that at NAB, which is basically a pure JavaScript implementation using currently, but it's independent of the transport layer, using currently the WebRTC data channel in an unprotected mode with an SRT kind of layer on top of it to get very low latency data to the browser, and then repackage in the browser the TAS to fragmented MP4 in order to put it into the media extensions of the browsers, so we can play it back. With this solution, we also showed at NAB, and I was actually a lot faster than I anticipated, so now I have a lot of time for questions if you have some. Yep.
So the whole time it's going through the Azure backbone, it's in SRT?
Yes. I mean, SRT is a whole glue end-to-end in this setup. Yeah.
You were saying that you have local hublets on Windows and Mac. How about Linux?
Right now we haven't compiled it, but there's no reason why not. Yes, we have all three basically, and it's basically when you're in a dashboard for the SRT Hub, and you say I want to create this connector hublet on the input, then it gives you a link to download the flavors, and you can just basically from that dashboard directly click the link. It downloads the connector component. You run the installer. It asks you to pair to the SRT Hub. The hub will give you the pairing code, so you pair it up. And once you paired it to your account, it's sitting there. And you can use it anytime when you come back, right? And that will surely work on Linux. There's nothing stopping it from that. Yeah.
Can you use it to deliver to the clients?
Repeat the question.
Yeah, okay. Can you use it to deliver to the clients? I mean, in general, yes. It really depends on how many clients. Huh? You can directly use the SRT Hub with generic SRT output to the hundreds and thousands, but it's not a CDN. Right? You wouldn't deliver to millions. So, but that's the cool thing about the hublet. We are working with partners to create hublets, so we can just plug in, like what we did with Epic Labs. That hublet was basically a handover to Akamai with low latency CMAF. And it could be any other CDN, like the Microsoft CDN, it could be Limelight, it could be any. That's a nice thing about this ecosystem. So it's not this solution is not a like Haivision solution. These hublets are third-party services, and we don't charge for it. So we let you build it, integrate it into the solution, and the moment the SRT stream hops over to your hublet, into your service, that's your thing. That's not our deal.
And do you know if the element of on-prem is able to transmit as SRT? And also, Akamai CDN is able to ingest it as SRT?
That's a question you should address to them. They are not, so Elemental is not part of the alliance. I don't know if they implemented SRT yet. They're constantly interested, and we have been in contact, but that's a question you have to ask them. I don't know.
That should be on their program.
Okay.
Don't know when it's coming.
Okay.
Well, and just to follow on that, we can take SRT from the routing graph and then feed it into, transmute it to RTMPS and output it into a CDN or to another protocol,
right,
and output it into Akamai that way. So if you have a service, and similarly with the connector, we can bring a stream on-premise as RTMP, bring it through the connector and send it as SRT from on-premise. So if we're going with or transport stream,
yep,
if we're going with a non-SRT workflow, there's multiple ways that we can take the content in, flip it and then deliver it through SRT Hub and then flip it back out on the other side.
Right, and we have shown Haplits at NAB for Facebook Live, for LinkedIn Live. So those are RTMPS solutions, basically. So, but the advantage is that you are already in the destination region. So you don't have a problem when it comes to the transmission because it's just basically a local transmission. You did SRT all the way there, then you flip it to RTMPS and you just hand it over in the data center, so you don't have any contribution problems that you typically have if you want to do RTMP contribution from far away into that region.
And do you do Azure, if Azure Media Services bring in ad markers in the SRT?
Well, that's an implementation thingy. That would be a hublet for processing, right? That's something somebody has to implement. For example, Microsoft need to go in and build this hublet. And since we have a really good relationship, they're actually here in the room, there's no problem doing that, yes. And it really depends on the workflows that the people who want to use it are demanding, and then we can hook in whatever service we want. Nice. Okay. Everybody? And thank you very much.